Let's try to take the green infrastructure idea to localization at watershed scale. This is the Ocean View Growing Grounds, as they call it, which is a community garden in the Cholas Creek in Pueblo Watershed in San Diego, being run with UCSD and its partners. So this is showing a food forest in here. So it's using vacant lots to do, and there is the Cholas Creek, which is a hydrologic structure that's already there, to implement green infrastructure for localization. So this is a great example of a field scale experiment where data can be taken and success and failures can be logged, and education training can happen, as you can see with these people, either community members or students, researchers, and so on, right? These are always great. Here it is showing Bioswale at the OVGG in San Diego, California. So I will show more specifically what we mean by Bioswale. It's a way to manage the runoff and groundwater percolation and interactions with the vegetation and so on and so forth. This is the site that we talked about before in terms of the community site, so we called it something in the previous chapter. So this is the unique thing is that it is on an international border between San Diego and Tijuana, Mexico, and the idea is to remember that the watersheds don't care about boundaries put up by human beings. So if you want to do localization and green infrastructure, you have to find a way of working across the boundaries if you want to be really successful in achieving the goals of localization and climate solution. So this site here is using GIS and so on to identify suitable sites for a green infrastructure. You can see that it's got this character with the Pacific coast sitting right there. I think La Jolla is probably somewhere there, but I don't want to go into that too much. There is a huge Navy base in San Diego as well, and with that, the Bioswale concept, the diagram we will look at here, is showing dirty and polluted water from rooftops. So it's a human natural system interaction from roads and parking lots entering the bioswale. And I think we have mentioned it before, but road transportation can actually be a major source of nutrients and hydrocarbons and oil spills into local water bodies, because all the cars drip always leak oil and sometimes gasoline. So air quality problem apart, they also have an impact on water quality through those leaks. Water is slowed down by various plants and rocks, and pollutants settle out. So idea is to filter out the pollutants before they get into water bodies. Clean water infiltrates the soil, so you have to create a structure where you remove the pollutants and let the water soak in. Water enters the perforated pipe and is slowly absorbed into the ground. So it's the idea of slowing the runoff, reducing the runoff and sediment loading as well, and pollution loading, nutrient loading as well. Excess stormwater exits the bioswale and flows through the pipe into the recipient cleaner than when it entered, and the amount significantly reduced. So, as I said, all good things coming out of it, right? So you can see an example here as a schematic. There is the parking lot, or let's say the road. There is the walkway, and there is the bioretention swale. So it's got multi-layer vegetation with trees and some flowers, some typically tend to be perennials, curb notches to manage the runoff and water flows. You can see here shown as some kind of a flow from the, let's say, watering the gardens or bioswales, and there is the perforated pipe that's going to take the water, cleaner and in less quantity to the recipient, which is typically the stream or the river or the coast, right? There's the bioretention soil. There is the mulch for fertilizing and making the soil healthier over time for the vegetation, and there's a gravel base which basically filters out various sediments, leaves, matters, and other things. So this is a broader example from this paper here, which is showing a watershed level green infrastructure in fuller glory. Okay, so this is a schematic of low impact development practices. So that is basically green infrastructure's goal as well. At the watershed scale, which includes a river, all these little catchments, agricultural land, natural land, so working lands, natural lands, and parking lots, malls with bioswales in there, campuses, hospitals, maybe little industries, and residential neighborhoods. So you have bioretention system, which is here. You can see implemented in this area right here in the corner. Green roof, which you can see here on buildings, larger buildings. Rain gardens in residential neighborhoods to prevent runoff, filter out sediments, nutrients, and so on. Permeable pavements, you can see these allow water to percolate instead of running off like paved lands tend to do in unplanned urban growths. A bioswale, where is the bioswale? E, there is what we saw before. And rain barrel that is doing rainwater harvesting. In fact, you can, it's right here. So you can take buildings like this, and in addition to green roofs, if you also do rainwater harvesting based on the rainfall rates or amounts per year, you can even collect significant amounts of water for gardening and other municipal purposes. So it's incredible combination of things. So those are good examples of localization and green infrastructure for increasing resiliency, as well as combining green infrastructure with localization at watershed scale.